Good morning, everyone. You're listening to the Sci-Files, an exposure segment featuring Michigan State University student research. We're your co-hosts, Chelsie
and Daniel Puentes.
Today's an exciting day. We have 3 people here with us. We have Brady, Jeremy Rapp, and Ben McCarthy. Jeremy, can you please tell us a little bit about yourself?
I'm a graduate student in the Department of Earth and Environmental Sciences. My work focuses on the food, energy, and water nexus, specifically food for myself. But to talk a little bit about what that nexus is, which is kind of a jargony idea to think of, it's all of the effort that cumulatively goes into the food that's grown, how it's grown, and how people end up eating that food across the world. So my research specifically uses artificial intelligence, don't think like Terminator, using just the really high-level math algorithms that go into that level of computing, combined with a lot of the cloud computing stuff that's coming from Google and Amazon in order to process a very, very large amount of the satellite data that we have from the different networks across the world. So places like NASA, NOAA, European Space Agency, they make all this data available. I take that data, provide it to this neural network or these artificial intelligences, and have that classify imagery for where farmers are using water to keep their crops growing. And so this is a really complicated thing, which is why we've had to turn to artificial intelligence, because someone can't just go through by hand and figure it out. It would take too much time, too much effort. And so I like to think of myself as sort of working as a teammate with this artificial intelligence, that we can both learn what's going on and generate better products that would eventually help inform people and also help inform the directions both from the water and the energy standpoint.
Very nice. And then Ali and Ben, can you elaborate a little bit more about what both of you contribute towards this research project?
I'm Ben. I work on the energy aspect of the food, energy, and water nexus. My work focuses mainly on how much energy it takes to irrigate the fields that farmers use. I look at how changing technologies affect energy consumption. So if you are a farmer and you have, let's say, wheat that you grow, and you use an old type of irrigation system that uses a lot of water, you tend to use a lot of energy, and then you decide to switch into a more modern system, which has happened in recent years. I see how that impacts the amount of energy you use, whether it's from electric or from natural gas or from diesel. I developed a code that can calculate. It can't be applied to, as long as I have the data, I can apply it anywhere else. But right now I have for Kansas how much energy goes into irrigation using those different factors. And that adds on to the water aspect of it that Ali works on.
Thanks, Ben. Like he mentioned, my name is Ali, and I work on the water aspect of the FEW nexus. So we've already talked about water, we've already talked about energy, and I look at how different irrigation systems in agriculture affect the groundwater table. So Ben mentioned how different irrigation systems affect energy and the amount of energy that we use, but I look at how that affects the water that we're using, and in general, how we can make the water that we have sustainable for more food and more irrigation in the future.
Thank you, everybody, for those incredible introductions. Jeremy, how do you make these maps? Do you use a technology known as Geographical Information Systems, also known as GIS, to make them?
We do use GIS in this work, Geographic Information Systems, as Danny said it. What it does for us and how we use it, essentially it becomes the tool that we use to make these maps that we're working with and then explore how those systems are changing through time.
Is it a software that anyone can download online or something?
There are free versions of GIS that you can get. If you are a student at Michigan State, you have access to some of the paid-for ones. ArcGIS is the most common one that I think a lot of people use, and that's sort of the industry standard. Some of the work that we do, because of the level of, or specifically the work that I do, the data needs have gone past the ability of ArcGIS and some of the traditional GIS systems to handle. So we've moved largely to like Google Cloud to deal with that issue.
And then is the Google Cloud what provides that AI aspect of your project?
Yeah, so AI, the way it's actually utilized is more like any other normal coding. You have functions that you're using and you're plugging and playing sort of with your data and seeing sort of what outcomes you're getting. The way that ends up being used is you're working in the cloud. All of your coding is done in the cloud. All the processing is done up there, but it's behaving just like any other scientist would use Python or R or something like that.
And Ben, you had mentioned that you do some coding as well in regards to the energy aspect of this. Can you please explain what you do and if you use GIS as well?
For my project, I used, like Jeremy mentioned, Python. Python is a coding language. It lets you more directly communicate with a computer and tell it what to do. And for scientists, is a very common language to use to try to do more computationally heavy projects. So I use it to both use GIS maps, like the ones that Jeremy produces, and I also use it to grab government survey data about these farms that are being used and the different irrigation technologies. With the code that I wrote, it uses both of those. And I grab some of the map products that have been created by our lab, and they give me information about the region in terms of how much water there is underground, so the groundwater, where on the ground that water is at, so the groundwater table. And it gives me properties of how quickly the water goes through these different rocks underground. Using all this, I was able to assign a value for how much energy different systems use, and then calculate total energy for each farm. And then I aggregated it all as a big product for Kansas.
Thanks for that large overview about your research. I actually have been learning Python myself, and I find this very interesting. I was wondering, how do these people actually measure the amount of groundwater in the area? Do you go out there and conduct these surveys, or are you just receiving them from Kansas?
It's a great question, and that goes back to making these map products. So one of the best ways to do it is to actually go out and either collect the data yourself or have some sort of instrument at a specified location that you know that automatically collects data. In Kansas, for example, we have about 4,000 wells that were dug up by the government agency that regulates groundwater, and is called the Kansas Geological Survey. And they go in there, they make these monitoring wells, and with that, they can measure how deep the water is. Then they put that into an online data system, and I can acquire it online. So that's how I use it, and that's how we make some of these products as well.
Since we are in Michigan, I would imagine it's a little bit hard for you to communicate with Kansas, and it's a little bit far away. Why are you using data from Kansas instead of in Michigan?
It actually goes back to my last answer. Kansas has a lot of data. We have the survey data, we have the information from the farmers. They banded together and decided that we are using too much water and we need to keep track of how much we're using. So that is why Kansas is one of the places. And they worked with the government to try to get these survey data out there, and we end up using it.
I'm starting to notice that Ben studies a lot of information that deals with water and the water table. So, Allie, how do you study the information about the water table differently from Ben?
A lot of the same data. I'm actually using the process data that he has gone through and cleaned, so that's very helpful. But I take it one step further, and he looks at it on a well-to-well basis. And what I do is accumulate all of these wells or bring them all together so the data that we have becomes not just point data, but it becomes like farm level data. So instead of like one farmer having 3 wells on his farm, we take all of the averages of these well points and figure out a farm level water use. So that's something that I'm looking at. And then also, how do we identify different irrigation systems? Because like Ben said, we have great information for Kansas, and that's really awesome, but we don't have that information everywhere else. So I use Jeremy's map products and the products that he's making for not just Kansas, but everywhere. And I use the information that Ben has given me from Kansas and look at all these different places and how do we identify different irrigation technologies based on what the irrigation looks like. So if you take a picture of irrigation from an airplane and you're looking at it and you can see a circle in any farm, you can say, okay, that's probably irrigated by a system called center pivot because it's out of the center and irrigates water like a sprinkler. And then there's other systems like drip systems that you just have really long hoses that run through the fields, and that creates a different pattern that you can see from airplanes. I'm looking at how can we identify these different systems and provide the information that we have in Kansas everywhere else.
Now, to remind our audiences, can any of you tell us about what the final goal of understanding these irrigation systems are? Is it to create a better way to create food, crops that is going to be easier for the future, or is it more have to deal with geological sense?
In a broad sense, the reason we're doing this research is because water is a very limited resource. These aquifers that we study and the regions that we're looking at, in the last century, we have been taking a lot more water from these systems that gets recharged into them. So we like to look at them from the point of view of someone who's looking at sustainability. They're seeing that these systems are not sustainable, the way that we are growing crops, and the attitude about conserving water and energy consumption needs to stay within the realm of something that we can carry on to the future. And so we try to expand the knowledge of these things and hopefully suggest, or at least for now, we are analyzing it and telling you the impact of what these farmers are doing.
Have there been any direct results of the work that has been done in your laboratory in Kansas so far?
We do have some people that are working in Kansas. We work directly with the Kansas Geological Survey, and they have implemented some of our results, but none of those results are actually writing rules because it's hard to be in Michigan and then go back and say, okay, we're going to make these rules for Kansas. So most of the stuff that we've done has been a lot of data analysis of implementations of policy or when they make policy in Kansas, and then we see what happens after that. So the biggest thing that we've noticed is a Sheridan 6 Lima, or a really small county level place in Kansas that has put water caps on the amount of water they're using for irrigation. And we look at the impacts of that, and it turns out the water caps are actually helping with groundwater depletion, or the amount of groundwater being taken out of underground. So that's good that we have that data, and also that our data is helping analyze that. But we haven't made any rules for Kansas because, again, we're in Michigan.
Jeremy, this question is directed towards you. Since you're the one who makes the maps, I'm assuming that you look at the topography of the satellite imagery that you get. Can you please explain a little bit more about that, but also about how would the topography impact the irrigation? Like if a high plain or something would need more water versus like a flat land or something.
So that's a really good question because it targets how we even understand these landscapes to begin with. So topography, meaning the elevation and how that changes over an area, and the impact of what that's going to have on a system is a big component of what's going on, but also largely environmental properties. So how much rain a system gets, how much humidity there is in general. All these different things impact what's going on and what we can see because they drive how green a landscape is to begin with. So we take that consideration in, and when we start expanding out of areas like Kansas, we have to start turning to AI because a single person can't conceptualize how all those things are interplaying. So we consider topography, we consider climatological data, the history, environmental data, all this stuff going in, and try and build a framework for artificial intelligence to help us pick out these irrigated fields. And Kansas is kind of the bed of that. Topography specifically in how it would impact things is it affects where the water table is. It affects how far farmers have to go down to pull water out, which drives both the energy side of things, and also, depending on the technology that farmers are using, it can impact how much water they have to use because of the soils that are there and how fast those drain. There's a huge amount of impact with these different variables and sort of the interface that's there.
Well, it sounds like each of you are all masters of your craft at this point in the game right now. Could you tell us a little bit about any results that you've found during your research here?
In terms of energy use, we have gotten some results. I looked at how changing these irrigation technologies has affected energy use. We are looking at, like Jeremy said, it's a whole dynamic system. What we've seen in general is that there's no major change in how much energy has been used over the last 20 years for the data set that we're looking at in Kansas. Then if you delve a little bit deeper, we see that as these systems have been changing, water consumption has also continued. These aquifers, like I mentioned, the whole reason for our study is that we're looking at how much water is being taken out versus how much goes back in. The water table for the groundwater has been decreasing steadily. It's gone from around 150 feet on average to around 100 in the last 20 years. That's huge. That's a ton of water, especially in the area that we're looking at. What the more efficient technology has been able to do is offset the amount of energy that you need to pull water from deeper. When you use these more efficient pumps, these more efficient systems, it cuts right at the farm how much energy you need. But if the water table keeps going down, it's only been able to offset it.
Leading off of that answer, Ben, he talked about how the water table is decreasing, and that's true. Even though we're going to more efficient irrigation technologies, we see that farmers on average are increasing the amount of area that they're irrigating. So even though we're using water more efficiently, we're irrigating more area. So we're not actually decreasing that decline. We're not stopping the water table decline, except for in areas where they've put direct water caps or water usage caps on how much irrigation or how much water they can use for irrigation. So in those areas, we do see that the water table has stopped declining at such a fast rate because they have caps on water use instead of just increasing their amount of irrigated area because they have more efficient technologies and they have more water essentially, or water enough to spread out over larger places. They're using less water. So that's good.
So kind of going off of both of those, we're talking about an area, specifically Kansas here, where it's more obvious why farmers would need to use water in the first place for their crops. And so one of the goals that we have now is to expand outside of Kansas and the High Plains to the different areas. California's Central Valley is always a popular one, and we're working there now too, as well as Michigan, which when you start talking about farmers needing water to help their crops grow, you don't think of Michigan. And it's a really interesting area because a lot of scientists can't quite explain why farmers would be doing that anyways. And so the maps that we're trying to create and use here, they'll capture that information and how that's changed sort of behind the scenes. Because these other areas that really, really are unsustainable, obviously unsustainable right now, get all of the attention. But this is a phenomena that's happening everywhere, across the United States especially, and across the world as populations grow. Just because you need more food. And we want to get ahead of it, specifically for Michigan, because it's going to be the future of crop growing. The Midwest is when we start to actually run out of water in these areas or it becomes too hard to grow there. And if we're already losing water to irrigation in these places, then it's going to be catastrophic if we're not aware of how we can get ahead.
So to give an example that kind of relates to what Jeremy was saying, a place like Texas, right? There, the way that agriculture works is pretty similar to Kansas, right? People come in, you have farmers, they drill a well, you start using your water, irrigation systems change depending on your needs, on more efficient systems that come out. However, in Texas, they don't have that much regulation for water use. All you have to do in Texas to have a well and pump water out of it is pay a one-time fee. And there's no limit to how much water you use, no limit to, there's no interaction usually, unless you're friends with your farmer. There's no really interaction saying, let's regulate, let's put caps on what we're using. In Texas, there's papers that already came out that say that within the next 50 years, their aquifer is going to run dry, at least a portion of the High Plains where they're at. So it's very unsustainable.
Thanks for explaining that, Ben. These are all really important topics that I think that people need to be very aware of.
I think one of the important aspects of expanding the awareness there is who you talk about is aware. Who is the person that is benefiting from this? And largely, we're working to create these data products, understand these systems, but we all want to push that even further and inform the farmers that this matters, the people that have grown up and lived in here and hope that their children will inherit the same land that they've tended. We want to provide them the tools that will allow them to sustain that into the future, because ultimately they feed everyone anyways. And so if we can work to benefit them, we all want to pitch in there and get that information out.
Part of that is being able to explain the science that we do to people who don't work in the sciences. So that's one of the reasons, obviously, that we're coming on the show, because we really believe in communicating our science to non-scientists. So hopefully this was interesting and informative. But also, we want to be able to make science attainable to everybody and accessible to everybody, not just people who work in a university or people who work in the education system, but anybody who can benefit from the science should be able to understand the science. And in order to fully be able to explain what you're doing, you have to have science. So all of us have a really big passion for communicating our science to non-scientists, and hopefully we'll be able to do that with our master's degrees in the future.
Well, thank you all for coming on to the show to talk about your research. I agree with you, Allie, that it's incredibly important to actually get this research not only to other scientists, but important stakeholders that have a role within the research and the application of it. You've been listening to the Sci-Files on Exposure. Thanks for Jeremy Whiting, our general manager, Olivia Mitchell, our station manager, and our program managers, Amber Knutsky and George McNeil. Thank you to all of our listeners that joined us this week. And remember, the truth is in the science. Any comments and questions can be directed to scifiles@impact89fm.org. We'll see you all next week on Sci-Files.